So let's deal with these colours. So I have an example of how the colour overlay goes on the original machine. It's just like a red and a green band. And you can see here how it's operating. So looks like the red band goes just under the scores and just over the top of the top level aliens, the octopus guys. So let's try and figure that out. So first of all, we need to figure out what values are here. So let's create a color and let's switch on Y, and we'll use this to set the color. So the default is going to be color equals color.white. Okay, so case int n when n, let's try and estimate this. Let's say, so we've got 1, 2, 3, 4 characters. I'm assuming they're 8 bits, so that's 4 times 8, and that's embarrassing after it. So 32, and it looks like 1, 2, 3, another 4. So 32 to 64 looks like that, what that might be. It's greater than or equal to 32, and n is less than 64. Color is equal to color.red. Okay, now I'm not going to be able to see that straight away, so what I'm going to do here, that's the way it's going to be eventually, but I'm going to invert this so I can see where the color bands are being drawn. So color black, and then we'll do the background in color. What doesn't it like about this? Control, oh, I didn't put a break. Okay, that looks right. Bit weird looking at it inverted, but okay. Yep, looks like we got that one on. So for the bottom of the screen, so what, we've got 1, 2, try and eyeball this, 7, 8. So 64 from the bottom is 256 minus 64, 192. Okay, let's try that. So case when n is greater than or equal to 192, and this is green. And it looks like it's one more above that. But actually, I'm going to keep it like that. It keeps this text here in the white area. But we need to put 3 in white, I believe, and the credits in white. Okay, so that looks like 1, 2, 3. So that's 24 pixels in. And this time we're looking at X. So if X is less than 24, then color is equal to color.white. Else we'll set the color to green. Let's see if that works. Right, but Y needs to be 2 pixels. So Y needs to be from 8 from the bottom, right? 8, 16. So 2, 5, 6, take this 240. So Y has got to be greater than 240. So let's do this here. If Y is greater than or equal to 240, where's this else? Oh, this is terrible. Color equal color.white. That's awful coding. Oh, well, yeah, that's not right, is it? That needs to be green. Okay. Okay, that seems right. Then we need the credit display. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 characters. 224 across, right? So take away 88. 136. Okay, so if X is less than 24 or X is greater than, what did I say that was? 136. Okay, so what we get now. Okay, I think that'll do. Okay, so let's invert the colors back. green doesn't seem quite right. Yeah, and I can see the thing hitting the top and turning red, so that's okay. Okay, I'm going to change that green to, I think, lime green. See if that looks any better, because that green didn't look right to me. Oh yeah, that's better. So that's the colours sorted. Okay, let's start doing these dip switches. So let's make our dip switches. So this is going to be a bool array, and we'll pass the Boolean array into the constructor. Oh yeah. So we're going to need to private Boolean array, dip switch array. Okay, I think I'm going to return it like that. So we'll set bool sw equals new equals, okay, and this is dip 0 checked, and we're just going up to dip 7. Okay, and then just return sw. So core dip switch array. There we go. Okay, in core we need to set dip switches. So let's make a public, because these can change obviously at any time. So public void set dip switches. And this is going to take a Boolean array, and dip is, and up here we'll call that function set dip switches dip. So that sets the switches. So in UI, when we have a dip switch changed, yeah, we just call core set dip switches dip switch array. There we go. That should set the dip switches as we need them. So let's check if that's working. We go switch. So dip switch 3 and 5 control the number of ships. Okay. So let's set dip switch 3 and 5. Hit reset and see if we get more ships. I'm hoping it's going to show in the attract screen. No, of course it's not going to work. I haven't implemented them in ports, have I? Muppet. Okay, so these are going to return values depending on where they are, which bit they are. So I'll make a little function to deal with that. So public, this can be private. Dip, we're returning an int, dip switch number, and the actual value we want it to return if it's 1. So int, we need to check if dip switch SW and 7. Right, so if that's set, we're returning value, and if it's not set, we're returning 0. So the first dip switch is dip 4 on port 0, which is on bit 0, so that's 1, has a value of 1. Okay, so that's dip 4. So this is going to be 14 plus dip 4, which has a value of 1 in this instance. Dip 3 and dip 5. So port 2, which we haven't implemented yet. So case 2, yeah, we're not going to deal with, I think this P2 is for cocktail cabinets, so tilt, obviously we're not going to set that. So it's just these. So dip 3 is bit 0, and that is a value of 1 because it's in bit 0. So dip 3, 1. So dip 5 is bit 1, so that's 2. So that's plus dip 5, which has a value of 2, plus dip 6 is bit 3. That's the extra ship. So that's 1, 2, 4, 8. So dip 3, 8. Okay. Dip 7 is coin info displayed. So that's 1 to 8. Bit 7. So dip 7, 1 to 8. Plus dip 7, 1 to 8. All right. Let's put dip 3 and dip 5 on and see if we get more ships. Yep, there we go. Buttload of ships. Okay, so we've got dip switch is set. All we need to do now is implement buttons. Well, we need to implement buttons and sound. We're going to need to buffer the buttons because the way the emulator works, it executes a block of instructions and then pauses and then executes another block. And if you've got a key press event happening in that pause, the emulator's not going to see it. So we're going to need to buffer it. I'll create a new class for this and we'll call it game button. So new item, game button. So public game button. What we're going to have to do is pass in whatever key. So that's keys. We need to include the namespace here. And this is the key that it's using. And what we'll do is we'll set up a static collection. So private static dictionary keys, and this is a game button. Call it buttons equals new. So as we come in here, we can add this button to that collection. Buttons key equals this. We need something to deal with an action. Public static, and this is a key event. So let's call this key event, and this is the key that's coming in, and a boolean to say whether the key is pressed down or whether it's been released and gone up. So we'll call that down. We're going to need a queue of bools to record event states, and we're also going to need the current state. Private bool current state. We'll set that as false to begin with. So as a key event comes in, we need to first check if that key is registered in the buttons, so we can get the game button object. Okay, now we need to check if the state that's being recorded is different from the current state, and there's been a change in the key's status. We're in a static context here. Then we can change the current state, and we can enqueue the event. Okay, I'm missing a bracket. There we go. And now we can read the state. Same thing as up here. So if the key is registered, we'll grab the button. Otherwise, we'll just return false if nothing's happened. If the key isn't registered, we need to return enqueued values, and if there's no enqueued values, we return the actual current state. This will ensure that all events, all key events, will actually get passed to the emulator rather than some getting missed. Now, these are going to be accessed by both the emulator side, the emulator's task, and the UI thread. We're going to have to lock on this, so we can lock on button, and then down here again lock button. Okay, so that should deal with our buttons and buffering them. And in shown, all I need to do is just register the buttons. I don't even need to save the objects. Okay, so that registers all the game buttons. Oh, we need to set events for keys. So okay, in design, we'll just use key preview for this rather than mess about. So I'm going to turn key preview on, so the form will receive all keyboard events, and we want key up and key down. Okay, this is going to be game button key event key, so that's e.keycode, and this is true because we're pressing it down. And then the key event for key up is going to be the same but false. So in core, we just need to deal with the buttons being pressed. So credited bit 0, so that's D5, right? You know, I don't like this. Let's set the keys that we're going to use. So I'll do that up here with static members. This could be changed to, to a settings file or something, but for now, okay. I don't like having to use literals in multiple places like that. Actually, no, I can make that private. Okay, we'll go back to UI, and we can get rid of all of that now. Okay. So in core, we need to set up all of those keys. Okay, that's better. So we're going to need something similar to dip. We'll call it GB for game button. And that's going to be keys, key, and the value that we want if the button is down. Okay, so we're going to return game button dot key state of key is value or it's 0. So port in, What port deals with the buttons? 2. No, it's port 1. Okay, so 8 because that one's always on. So credit is bit 0, which is 1. So that's going to be 8 plus, this is going to be game button, and credit is key insert, and it's 1. Hopefully those are all the keys. We should be able to play the game. We won't have any sound yet, but let's see if that works. Oh no, I've got build errors. Plus, not comma. Okay, let's give that a go. So let's press 5 and see if we get, yep, there we go, coin inserted. Press 1, game playing. And yeah, we can play it. You can see the jerkiness on the movement of the bass at the bottom. It's just, you know, one of those things. It could be improved. Just need to mess with the CPU emulator and give it a little bit better resolution. It didn't matter for the Altair emulator too much because, you know, its output is through a serial device. So that type of thing isn't really noticeable. But on this, of course, it becomes very much more noticeable. Okay, well, that's working. So the only thing really left to do is to implement the sound hardware. So I'm going to create a class for each sound. Well, I'm going to create a class for sounds and then create instances of them for each sound. Let's make a new class. I'm going to call this game sound. Let's just save this. I need to include the N-Audio library. Okay, so N-Audio is now installed. So what I'm going to do, first of all, I'm going to create a game sound and use the standard way of playing a WAV file and try and show you what the problem is with this click. First of all, we're going to pass a file in, okay, and we're going to set up the sound using that. So the first thing to do is to create a wave stream. Okay, so that sets up the stream. Then we need to set up an event, and we say output.init with our stream. Okay, and I actually need to save that. So up here, that can be read only because it's made by the constructor. And then we can set up a public void play, and then we say output.play. Okay, simple enough. So that's our game sound class that's just going to play a WAV file. So let's go into core, and in the constructor of core here, I'm just going to set up a basic file. So say game sound smd equals new game sound 3.wav and then smd.play. Hopefully that will play the sound. Yeah, can you hear that click at the end? Yeah, that's no good. You can't have that happening every time it plays a sound. So we're going to need to get around that somehow. So a way we can get around this, I'm going to create another class here, and I'm going to call it G wave stream for game wave stream, and we're going to extend wave stream, and we need to implement the abstract methods. So let's create a constructor, and it's going to take a wave stream as an input, which is going to be the source stream. Now wave format, okay, and we'll store the format and then return format there. Length. Now the length I'm going to set as long.max value, because what I want to do, I need this sound to play forever, right? It's just going to sit there playing all the time, but it's mostly going to play silence. And what I want to do when I want to actually play the sound, I'll just set it to output the wave data and then go back to silence again. That way you don't get the click at the end. So in order to make it look like it's going forever, we'll put long max value, which I mean, it will eventually end, but probably in a few thousand years or something. So position, we'll have a position variable and we'll get that, but we don't want to set it, so we'll leave set as not implemented. And read, we're going to return count, so we're always going to return the amount that it requests. And what we're going to do up here is we're going to save this wave data. We'll set up a byte array, which is going to be our stream data. I can get rid of all of this now. Okay, stream data, sorry, it doesn't go in that one, it goes in this one. And it's going to be the length of the original source, so source. Okay, now we can read the stream data into this array. So that should take the stream, the information from the original source stream, and save it into our byte array here. So at the end of here, we can actually dispose of the source stream. Right, so down here on read, we've got an offset and count. So for offset, then we'll go for int index is equal to offset, I is less than last, and I plus plus. And for now, I'm just going to say buffer I is equal to 128 for silence. Okay, so let's set up a source position, and we'll set this equal to -1 to begin with. And here, source position is equal to -1. We just put silence in there. Otherwise, what we put in is buffer I is equal to our stream data source position plus plus. Now, if the source position gets to the end, so that's going to be the stream data length, then we'll reset source position back to -1 so that it will start playing silence again. And we need a play event in here, or a play method. So okay, and to play it, we simply set source position to 0. Yep, so then it will start putting audio information from the beginning of our stream data into the actual stream that's being fed to the sound hardware, and then it will end with just normal silence, and that should take away the click at the end. So up here, we need to first create our G-Wave stream. We'll call this output, G-Wave stream output. Just call it stream. And this is going to be a new wave file reader of our WAV file. Now we can set up the event, wave out events. We'll call this output. Then output, we can initialize with our stream, and stream we can then start to play. Play here is just going to be stream.play. So what this is basically doing, it's setting up my custom wave stream, which sits there playing constantly because it gets started, and anytime I actually want to play the sample, I set that sets source position to 0, which starts feeding the source, the actual sound data, into the stream until it ends, and then it goes back to silence again. So let's see if that works. I'm not sure I've done that right yet, but we'll see. No, we've got no sound. Okay. Oh, I haven't set up the sound, have I? And snd.play. Okay, see if that works. Nope. I need to say output.play. Sorry. Okay. Try again. There we go. And you can see there was no click at the end. So we need to load in all our game sounds here. Okay, so there's all of the sounds, and they're loaded in there. So all we need to do now is to play the sound whenever we get the relevant output call. Yeah, these are actually bits that play these. It's not a discrete port. It's bits within a port. So what I'm worried about here is that I'm not sure how the hardware actually handles this. So if a sound comes in, does it, I'm assuming with the UFO, because that repeats, it's going to have to send a 0 to turn it off. But what I don't want to happen is if one of these bits is still a 1, so I'm going to go off and have a look and see what happens here. From what I can find, when the sound is playing, this bit is set to 1, and when the sound needs to stop, it sets it to 0. these bits are going to be on. So if I, this is difficult to explain. If I press fire, okay, and another sound occurs, say a UFO starts coming, or one of the fleet movement sounds, you know, the sounds. If that happens at the same time while fire is playing, this port is going to be called again, and that bit from my shot, my fire sound, is still going to be playing. So that bit is going to be 1. So if I just, you know, play the sound, if the bit is set, it's going to play it again. It's going to restart the sample. So I need to make sure that the sample is only played if this bit was previously 0. You have to try and think how I'm going to do that. I think I can do this by setting some kind of event system. Sound event. Okay, and what we're going to do is pass in a state. And this is going to either be a true or a false, depending on whether it's a 1 or a 0 that gets passed to the output instruction, you know, for that particular bit. So we're going to need to store that state. If the state is true, so that means we need to play it. We need to also make sure that the current state is false so that we can play it. You don't want to play it twice, right? Because we get 2 on bits from that port. Okay, otherwise, if the state is false, that means we need to stop playing. So that would be source, put a method in here, so public void stop, which sets source position to -1. Change that now to stop, obviously. So here we can say stream.stop, and then we can set the current state to the state that was just passed in. We should be able to just stream play them. Right, so yeah, I think that would work. I'll put a stop in here as well, and we can just do that. Better way of doing it. Okay, so making sure here, if we've got an indication that we need to play a sound, we make sure that we're not currently playing the sound, or that we're clear to play the sound because the state has been reset to 0, to false. Then we can play it. Otherwise, the state is set to false, so we stop the stream. That's probably going to work. So let's get back to core. Now we've set up all our game sounds here. So all it's a question of doing is, on output, is to play those sounds when they're requested. UFO needs to be a loop sample, so we'll have to deal with that separately. Port 3. Set case 3, sound.fire, sound event, val 2 is not equal to 0. That's it. Okay. And there's nothing else on there. And also we've got port 5, case 5. All right, see what we get. Hello, this is editing me coming in. You can see I'm right in the middle of editing this video, and I've noticed that the microphone that I'm using, it's a cheap-ass microphone, and it seems to be noise gating all of the samples that I'm playing when the game is running, and it sounds absolutely dreadful, and you can't tell if the sounds are being played right or not. So you're just going to have to trust what I say. What I'll do is I'll cut short all the playing sequences so that you don't have to listen to that noise for very long. And what I'll do is I'll put in at the end a proper desktop audio recorded version of me playing the game so that you can hear the sounds properly. But I apologize for that, and really nothing I can do at this point, but there we go. Okay, not quite right. So I don't think when it goes to 0, when the bit goes to 0, that we should be stopping the sound. I think we should just take that as being clear to play it again. So we can actually get rid of that part of sound event. See if that works now. Yeah, the sounds seem a little bit weird. They're not very regular. I think that might have something to do with the sound latency. Let's try and improve that. I need to put the latency in, the latency I want before I call the initializer on the screen, so that seems to have sorted that out. So this is now what I've got. Make it full screen. That seems a lot better, yeah, with that latency. Son of a... But that does seem to be working. So we need to figure out the looping for the UFO sound. So this should be reasonably simple. At the end of the sample, we just need to, instead of stop here, we just need to reset it back to 0 so that the sample repeats, right? Okay, well, we need to just set whether the sample loops. Let's give that a default value of false. Let's call this looping. Okay, and here, looping equals loop. We also need to tell the WAV file, the wave stream, that it's a looping wave as well. Let's put this in here. So bool loop equals false. Again here, and here looping equals loop. So stop will be called. So what we need to do here is, if looping, then we'll set the source position back to 0. Otherwise we stop. That way it'll go back. And if we actually call stop, then that will stop the sound from playing. So up here, when we receive the sound event, as long as the current state is playing, yeah, okay. Otherwise, it doesn't matter unless it's looping. So if looping, then we call stop. Hopefully that will deal with that. So let's go back to core, and then when we set up our sounds, this will set to true so that it's looping. And now we can set the sound event for the UFO. Okay. Give that a go. And then drop the volume coming out of the speakers a little bit because this is very loud. Okay, here we go. Should be along any second. Okay, well that didn't work, obviously. Alright, see what's happening there. Oh, I've got to... Sorry. Yeah, got to put loop there, haven't I? There we go. Let's try again. Okay, it seems to be working. There we go. That seems to be the lot. We've got a warning here. What's this? Oh. We've just got a few things to clean up, like read-only fields and stuff like that. But yeah, that seems to be it. Everything seems to work. So there we go. Space Invaders emulator successful. It's a bit clunky, a bit jerky, but yeah, that could be improved over time. But just for now, I think that's enough to call that project a success. So again, thank you for Benjamin for the suggestion. I hope you enjoyed that video and it was what you wanted to see. If not, let me know and we'll see what else we can do. But in any case, there we go. Thanks for watching and catch you later. Bye bye. Hi, so as promised, I'm going to switch OBS here over to desktop audio and play the game so that you can hear the sounds properly. So here we go.